So today is definitely unusual. Because I'm going to be gone tomorrow, I'm going to start with the review for today. The review of all of logs, pretty much. So let's just start with the most simple thing of all. If I gave you 5 to the x equals 26, I know you couldn't get it exact, but you could kind of estimate it in your head, because you can just go 5 to the first. Nope, that doesn't work. Okay. But then change it to an exact answer by making it a log. So give your best decimal guess. 3.9? Figure out what your best decimal guess is. And then figure out what log it is, and then use your calculator to actually get the real answer. You're predicting the answer. Now, step up, see how close you really were with your calculator. I'll pause for a second when you try that. Okay, so first off, you should be able to just go 5 to the second is really close, so it's about 2. A little more, maybe 2.1. But I suspect that it's even smaller than that, like 2.05 or something really small. But I don't even know. I'm going to do the log for it, though. You definitely need to know how to rewrite if there was only one thing you have to know on this test, because it's going to happen like 8 times. You're going to have to rewrite things this way and the other way, where you start with a log and you make it into an exponential. All right, so this, with a calculator, you would just say, well, it depends. If you have the new calculator, Math Alpha Math brings up the log with the empty box here for this and this. But if you have the old calculator, you've got to know it's log 26 divided by log 5. Either way, your decimal should have been about 2. Let's be more exact. All right, 2 point what? 02. Okay. I suspected it was 2.1 was even too big. All right, so let's go backwards then. What if I give you a problem that has a log and you have to write it out as an exponential and then solve it? So one of the bad things about this test is that it relies on exponentials all the time. Because once you rewrite this, it's an exponential just like last test. So if you struggled on last test with the exponentials, maybe you're going to struggle again, because these are just exponentials again. How do you solve that? You put it to the 1/3. Now on the last test, you wouldn't have had a calculator. On this test, you would. So now I just want to caution you that it's 2 to the power of. If you have the old version of the calculator, you better put your 1/3 in parentheses or you will get the wrong answer. 2 to the 1/3 power is your final answer. And did this trigger 2 answers? No. Nope, because it was an odd root. If that had been an even, though, there would have been 2 answers. Okay, so actual answer on this one, Proji, what'd you get?
1.25992.
That ought to be good enough. Raise your hand if you got the same thing. Okay, good. Yes?
So it just has to be even fraction?
I'm saying that you should put it your fraction in parentheses there, because do you get why some calculators do 2 to the power of 1 and then divide the answer by 3?
I'm not talking about...
Okay, then restate your question.
If it gives you a negative and positive answer, is it because...
First of all, it's not giving you a negative and positive answer.
If it does.
No, if it does.
When you say if it does, then the problem would have to be completely different. So if we had a problem where we did the square root power on both sides, I need to restate that, because otherwise if I just say, here's the 2 answers you'd have, other kids will be super confused because there isn't 2 answers on this one. But if I change the problem, so you put it to a fraction power on both sides that was even root, then there would be 2 answers. And now what's your question?
So if it was like...
What if there were 2 answers?
So if it was like 1/4, it would be positive.
Do you have a question about that?
Okay.
Okay. If there were 2 answers like this, then you would say, okay, then there's two answers because usually there's a variable in here and usually you get the absolute value of that variable. If there had been two answers, then you'd have plus and minus, and then you'd have to figure out if either one of them was extraneous. So you brought up a really complicated question, and I need to keep moving. On to the next thing, log base 3 of 1/9. This will test if you know how to do fraction exponents. Because if you can make that 3 to a power, then this problem becomes easy. I can make this into 3, and the first thing I do is try to make it 9. Well, that would be squared. But that's not 1/9. Oh, but it's close. Now it's 9, and how do I make it 1/9? Negative. So therefore the answer is -2, the end. All right. But there's not going to be much of that on the test because you could just use your calculator and just type that in, and it would do it if you know how to put it in right. And you would have got -2 for your answer. Okay. The next thing that is definitely on there is, do you remember when you have two logs that you can combine them? Let's try one like that.
What's that?
Hold on. That's log base 3 of x plus log base 3 of x plus 3 is equal to log base 3 of, let me see if I can make this work. I'm going to pause for a second. You guys can combine them to start with. I have to make this I'm going to put a 4 here. Actually, no, this could work. I'm pretty sure this will work. So what I'm trying to do is set it up so that you end up getting a quadratic after the logs drop out. And then you got to remember to set your quadratics equal to 0. And then you got to remember if you can factor it, you should. I think if I did this right, you'll get a quadratic. You'll have to set it to 0, and you'll be able to factor it. Give it a shot. All right, I'm getting verified that it did work. So if yours didn't, here's some thoughts. First, you should have combined it to log base 3 of x times x plus 3. These two parts get multiplied. And then this is just bringing it down, just copying it down. Then, since the logs have the same base, that is equal to that. You just simply set that equal to that. So x squared plus 3x equals 4. Now I'm going to subtract 4 from both sides. X squared plus 3x minus 4 equals 0. And then it factors x and plus 4 and minus 1, I think. Okay, and then I get two answers. X equals -4 and x equals 1. And are like warning spidey sense going off for anybody? Like warning bells? One of these two might not work. So you go check it in the original and you say, could I have put -4 in all these spots? No, right there. The -4 would have killed it. It also would have killed it when you put the -4 there because you can't have a negative in the argument. So that -4 is thrown out. Do you get how depressing that would be to do all of that work, get both answers, and then get it marked wrong because you didn't take an extra second and check it? Let's actually just check the 1 and make sure it actually works. If I put a 1 here, you remember the deal where if you have a 1 in the argument, this whole thing turns into 0. And then if I put a 1 here, I'll have log base 3 of 4 is log base 3 of 4. Ha! For sure works. Now I know the answer is 1. All right, so only check the answers that you want to get right. Okay. Next, this one's going to see if you remember some really critical properties of logs. Now, this one looks incredibly scary. But if you realize, oh my gosh, I can just simplify this stuff down to almost nothing. It just all simplifies away. Like, do you recognize this one where the bases are the same and therefore the answer's already there? And do you recognize that that one is like a 4 squared and therefore I can make the bases the same? It's always about making the bases the same. Do you know what to do with this 3 right here? If you don't, you better watch. In a minute, I'll show you. But then, the logs just simplify away and poof, it's easy. Okay, did you know that this part was just 2? Excellent, because the base is the same, the answer is just 2. If you're like, I don't get that, you've got to learn this pattern, but I will help you for now. If I made that into an equals x, I could, and then I could solve it, and it would turn out that x was 2. If you want to see how, it would be because log base 5, because I'm going to rewrite it as a log. Right now it's not, it's an exponential. And there's the base, and then you go over here to the x, and then you come back here to that, and that makes it really obvious that x must be 2. Okay, so all of that is 2. So I just replace it with a 2. So I'm just going to squeeze in the 2 right there. And then all of this simplifies to 8. Okay, I'm wrong. All right, here's what I did in my head. 4 squared, that was right. And then I times it by 3. No, I put it to the 3rd. Sorry. Do you get that this 3 could be moved up as a power, but I did it 2 to the 3rd. But what I really should have done is put it there, and then the answer is 6. The other way you could do it is to just say that this whole thing is 2, and then you times it by 3 and you get 6. Either way, it's 6. Now I have 2 plus 6 equals x minus 1. Well, that's 8 equals x minus 1. And then x must be 9. Raise your hand if you had 9 before I even said it. Okay, awesome. All right. One more reminder. Where can this 2 go? On the 5, how? 2 times 5?
X squared. 5 squared.
You make it 5 squared, you are correct. That 2 can go there. Why would you do that? Well, what if the other side was log base x of x? Ooh, crazy. That is true that that's all 1, but I would rather go that has to equal that. Because the bases are the same, that has to equal that. So 25 equals x. Boom, done. X must be 25. Okay, one last thing is graphing. If you have to graph y equals 2 log base 4 of x plus 3, are you going to be able to handle it? I personally just make an XY chart right away, and I try to find the asymptote, because I know it generally for logs, they look like this, but it's almost impossible to like go, I'm going to move it, I'm going to stretch it. It's so hard to do that way. So I kind of know it should look like this, but I want the points. And who knows why I started with -3. It makes the asymptote. If that part is 0, you have found the asymptote. Okay, well, you better find a few more points. You're going to have 3 points. You know why? Because 2 points can't tell you where a curve is. If I say make the curve that goes through these 2 points, you'd be like, I don't know. Which way should the curve go? How steep is it? So you need 3 points. And we will make it on the test so that you'd be able to find 3 points. Hint, your first one is really close to the -3 that we started with. I would put in -2 and see what happens.
Plus 3.
I heard 1 was a good call. I agree, because if I put a 1 right here, I'll have log base 4 of 4. That's as easy, and don't forget the times 2 in front. And one more thing to put in, somebody said 4, but I don't think they meant really 4. Because 4 plus 3 will be 7 in there. 4 is not going to be a great call. What else? I heard 13. You see why 13 could work? Because this becomes 16, and that's 4 squared. And there's also one more cool one. Do you get, it would be nice if this whole thing was 1/4. If that was 1/4. Well, that's an equation. And you go -3 and 1/4. No, wait. I'm going to write it. X plus 3 needs to be 1/4. Subtract 3, subtract 3. Oh, x equals -2 and 3/4. Why would that be a good thing to put in? Because when you do, that's a 3/4. When you put that here, you end up with positive 1/4 in there. And then it's 2 times log base 4 of 1/4. And that is 4 to the -1. So then you get -1 for the whole log part. Times 2 is -2. And I think it was 4 for this. Double check me. And I think it was 2 for this. And I think it was 0 for that. So I got those right? Yay. Now, if you can graph points and the asymptote's at -3, this should be easy. Go ahead and graph those points. We should see what it looks like together. Yes?
If you subtract 3 to 1/4, wouldn't that just be -3 and 1/4?
So what number do you want to put in for x? Help me understand what you're saying.
No, I'm saying the math equation where you did x plus 3 equals 1/4, and then you subtracted 3.
Yep.
How did you get -2?
It was like, think of it this way. It's like I have a quarter. That's the 1/4 part. And I have to give away $3. So I need $2.75 to make that work. Otherwise, use your calculator. You have a calculator on the test, right?
Oh, yeah.
So just 0.25 minus 3. And you'll find it's -2.75. Okay, here's what it should have looked like. That's 13.4. It's really hard to know, right? But -3 is where the asymptote was. There. I'm going to draw a line that doesn't obscure my points, but goes through them. There we go. There's my log graph. Okay, that's pretty much everything that we taught you except for application problems. On an application problem, they would give you an equation. And you just have to stick the number in the equation. So I'm going to give you one. Let's say you had y equals 205 plus 0.7 log of n. That's some weird equation I just gave you. What if I told you n? Could you figure out the answer? It wouldn't be that hard, right? If I told you n is 1, it'd make it actually really easy because I have a 1 in the argument. And this whole thing becomes 0. And then the answer is y would be 205. You know what I mean?
Yeah.
Or if I told you n was something weird like 11, you'd have to type all of that in your calculator and then add it to 205. It still wouldn't be that bad. But what's difficult is if I say y is 11 and you have to solve for n. Everybody do this one real quick. Use your calculator. This is the last review question because it covers, that's the last thing that's on the test, applications. You're sticking in 11 for y, and you solve. And they would give you a story around this. They'd say like, I don't know, the three-toed sloth has this equation for how much weight it gains, for how much leaves it eats, and you'd stick the numbers in the right spots. I'm subtracting 205 from both sides. What is 11 minus 205? How do we get the 0.7 off of there? Divide by 0.7. Correct. What is 194 divided by 0.7? Notice me not rounding. Then I don't know the base. But I do know the base. It has to be base 10 then if they don't tell you the base. And then it's a rewrite. If we didn't have a rewrite, I'd be kind of disappointed.
Because
That's the whole thing, yes. Logs, it's all about rewriting. Now this one happens to be a gigantic answer. I'm not even going to finish it because it probably is so big the calculator couldn't even handle it. But that's how you would have done it. Okay, so what is this new little thing for today? Your today's homework will be super easy. If I had said log base 3 of x equals 2, you'd know how to solve it, wouldn't you? Okay, but what if I don't say 3? What if I say e? Who has a decent enough medium-term memory to remember about what e is? Remember? It's a decimal. Yes? 2 yes, around 3. And you said 2.7 about? You are correct. That is about 2.7. But let me show you where it is on your calculator. Because if you just know where the E button is on the calculator and you have a calculator on the test, this becomes super easy. It's not like, what should I estimate it to? You can get the exact number for E. So, on your calculator, look with me. It's above the divide key. So you are correct when you said second divide key. Yep. So are you supposed to like write that whole number in there? No, here's how I would have actually done the problem. I would have still done this. I would have just known in my head, well, this is about 3. So I'm going to stick with E for now, placeholder. 2 to the second equals x. And then I can use my calculator to do e squared, and then I'm done. And the calculator right above the divide key, you see a little e there? That'll help you get e into the calculator. 2 to the second. And I got 7.389. Raise your hand if you got the same thing. Okay, good. Is that it? That's pretty much it. Wherever you see log base e, or just replace the e with about 2.718. The calculator can do it exactly. And you just haul the e around until you want to actually do it, and then you use the calculator to do that. All right. So one more. What if I had ln of 7? I bet you can tell that this is about a log still because we got the L there. If I said it was a log, what would you guess this would be?
L base n.
Log base n of 7.
Log base n
Come on, use context.
of 7.
It is log 7, but that would be log base 10 of 7, and that is not right. Nope, not base n. That's a good guess. Log base E. That's the context. This whole last part of the lesson here is about E. ln is short for log base E. If you can remember that, and wherever you see ln, you substitute in your head, oh, that's log base E. Then, if the problem was like, equals, well, 2 isn't going to be right. Let's say x. Then you can use, well, E is about 2.7 when you could do a log that way. Or there's actually a button for this. You see the ln button? It's right beneath the log button. So ln 7 has its own button. It's used that much. ln 7, you should have got about 1.94. Okay, all right. Last thing, remember what I said. What did I say to replace ln with in your head? That's like what? Log base E. So if I asked you to graph this, don't think that this will be like impossible. It's just log base E. And then you'd pick the same things. You want to make this 0, so you'd use -2 for the asymptote. You'd want to pick -1 so that then you'd get 1 in the argument. And you get 0. And then if you wanted to do one that would be smart, you'd want to set this whole thing equal to E. How would you get x plus 2 to equal E? Well, if you knew that E was about 2.7, which would be close enough for the graph, then I'd put in x is 0.7. And it would work nice. Because you'd now have 2.7 in there. 2 plus 0.7 is 2.7, and that's just 1. All right, so now I have covered absolutely everything that you would need to rock this next test. But I get if it was tomorrow, that would be a little stressful. Tomorrow I am going to be gone again for medical procedure, which I am very likely to be fine after, and then be back the next day. But you're going to have a review day tomorrow. You're going to work with a partner to just practice all hour. And then the next day is the test. But the next day is also a Thursday, which means I'll be here in the morning. So you even have an escape value. If you're like, I'm scared about this one, I'm feeling bad about this one, come in the morning. I'll practice with you on Thursday morning right before we take the test on Thursday. And then a couple days later, we take the cumulative. So if it goes badly, you know that you just have to study for the cumulative and do well on the cumulative, and that's like a retake. So there's all kinds of backups in case this doesn't go well, but I think it will. And that's all I have for you for today.